All right, hi guys, welcome back. We're gonna first start by actually just fixing the bug with the linked list. I figured it out. And then after that, we're gonna get into the undo. For blocks, we're gonna do both in this part. But first, let's just start with the bug that we found with this linked list right over here. So basically the way we're gonna fix this is pretty simple, right? This idea that I had right here was mostly right, but it was a little bit off. So let's get rid of this little debug print. And I'm actually going to do it a little bit different now. So I'm going to have t data is equal to front data. Simple enough, right? We have like a duplicate right here. Then what I'm going to do is I'm just going to call minus minus size. So we do that there. Then here's where we actually figure it out. So if front is equal to back, that means we're in the case where the size is equal to 1 and there's something we actually have to do. So what we do is we just delete the front, and then what we do is we explicitly make it so that both front and back are equal to null pointers. Another way to do it is to do like front equals back equals null pointer. Valid, I guess, but I kind of hate it. So we're going to do a little bit more verbose, but I think a little bit clearer. And then we get to our else case, which is this right here. And we're just going to take this, put that in there. And I believe that's all we need to do. Front, we get the temp front, we set it one forward, set the previous, and then we delete the temp. Super simple. And that's all we need to do for this one. This next one is the exact same kind of approach, right? We just do this. Then we do if front equals back, right? Then we have that case, which we'll do in just a second. This case is exactly the same as it was before, right? And in this case, it's exactly the same as it was here. We could do delete front or delete back. I just kind of like it this way. Front equals, right, null pointer, and then back is equal to null pointer. And that's it. That is all it came down to. So basically, we just needed a special case for when front is equal to back. Another way we could have done this is when size is equal to 1. And this just makes it so we are guaranteed to set both of these to null pointers. So let's go into main C++ and let's test it. So I'm going to delete that, do this. Now let's make /Sokoban. I'll just type it out. Right, and you can see now we're not getting a segmentation fault and we're getting the exact behavior we expect, where you can see we push to the front up until 9, so we get 9 to 0, and that's exactly what we get when we do a pop front. If I change this, for example, to, let's say, push back, and then I change this, pop back, I make it, I run it, and you can see we get the exact same output because we are now correctly using everything. So that's the linked list fixed. And now let's go on to undoing moves. Okay, so let's first get rid of this code because we don't need it anymore. There's also going to be some unused imports which we can get rid of. Very nice. And I know in the previous video I said we're not going to use a command struct. Turns out we're going to use a command struct. I was wrong. So we're going to make a struct command, and there's going to be two elements. There's going to be a bool, move block, and then there's going to be a point player direction. We need to add an import for point, and that's all we're going to use. This is going to be our little container for how we store commands and how we can actually undo commands. So now we'll go into Sokoban, header file first actually, Sokoban update, and we're going to change this so it returns a command. Then we're going to go into Sokoban C++, right, and let's go into that definition right here, and we're going to have our command. And also let's fix this real quick. Command. I almost typed CMD, but I'm going to try to be less verbose. Right. So now we have our command, and we'll come back to, well, we can just do that. Command dot player direction, command dot player direction. That looks fine. I want to go into the game C++ file while I'm thinking about it. So I have Sokoban update, right? And it's giving me this command. And so we're basically changing it so commands dot push back. Right? So it's going to be like this. And is that right? Because we div it, commands back data. Oh, I see how I was doing it. So we're no longer going to do it that way. What we're going to do is we're basically going to do this, right? 1, 0. And this is saying there's a problem, no viable conversion. To this, I think this is fine. We're just going to keep going on that one. So it was 0, 1. So we delete this, right? 0, 1, that's fine. Then what we do is we make it -1, 0. We do this, and then 0, -1. Makes sense. Now we're going to get a bunch of errors, which is totally fine. Right, so we do this, this, this. Now we have to add that. So we get this kind of error command to point. So let's check this. And let's start fixing all of these. So if like this happened, right, we would just return a.move block equals false, and dot player direction equals 0, 0. And since that's kind of like our default return, we can actually make it a little bit easier. cmd command. And then what we can do is we can do this, dot move block equals false, dot player direction equals 0, 0. That's our default. Well, actually, command and then command. Let me just fill these in real quick. Command, command, command. So our default is 0, 0 because if the play, it doesn't matter what the direction was, it matters if something actually happened. So in this one right here, right, where we're checking in the bounds, we don't want the player to move back. For example, if they pressed up, it would move them back if we actually use their direction in this, right? We can actually just change this real quick. Direction, so it's more explicit. So if we moved up and nothing actually happened, so you can picture like level 1, right, where you just have like a horizontal line. They move up, we don't want the potential for the player to move down when they press U. So if nothing happens, then nothing happens. The player direction shouldn't actually result in anything. We could also indicate this with like a moved player kind of thing, but this is a more succinct way, I think, of actually displaying that information. Maybe we'll want to add like a .move player at some point, depending on how well or not well this goes. But let's just keep going for a little bit, and then we'll see where we end up. Otherwise, in this one, we're just going to return command, right? Because there's nothing to do. So if the spot is not a block or a solid, we return. Okay, I see. So in this case, what we want to do, state.player is equal to this, command.player direction equals dir. We do want to do that. And then in the case where we're handling blocks, if this worked out, so this is where we're checking the next position, if you remember. If it's a block or a state or a solid, we don't want to actually move anything because the position where the block would have gone is already occupied. So that fixes that. And in this case, we'll again do this, but we'll also do command.moved block is equal to true. And that is that. Now let's close that. Let's go into game C++. Can't convert. So that's the reason why that is if I go to the game header file, it's using this. It should be command. Now we can get rid of that. I'm just gonna go for it. I don't think it's gonna work. Okay, so command header file. Do I have like two commands? I have two commands, I guess. Let me close this, close this. Let me cd src ls. Let's, for some reason it's capitalized, I guess. Let's try and make it now. All right, that looks fine. And now we have some conversions to deal with. C++. Let's go into line 118. Oops, nope. 118, there we go. So this is our, oh yeah. So we'll just actually get rid of this because this isn't helping us anymore. What else is there? Our Sokoban undo, so line 46. Now, so we'll do just Sokoban header file, right? So we have our command there, but this should be a command now. And now if we go to Sokoban C++, we will change it to, no, that's okay. I already changed this to Sokoban at some point, and I already changed this at some point while I was testing. Okay, so game C++, line 24. And so it's saying there's an issue because Sokoban update is expecting a command when really it's expecting a point. Sokoban undo, though, is expecting a command. There we go. So let's go back into Sokoban C++. That's good. This up here, though, is now good. Now let's see what the compiler thinks to think if everything's okay. So typing-wise, we're okay. Logic-wise, we are not. So we're right here. Well, actually, let's see if that works. It's not going to work for blocks, right? But undoing is working. And you can see I'm pressing U a bunch still, if you can hear that. And we're no longer seg faulting. So that's working. What's not working is our logic for the block. So what we can do is, this is like the undo direction, so let's change that. Right? So now what we can do is if, I'm going to do two things. Const point p, I think I'm going to need this, maybe I won't, is equal to state.player. So we get a copy of that position real quick. And if command dot move block, right, we need to actually handle the case where we move the block. And that means we're just going to take the block. If it moved over here, we'll put it back here. That's it. So what we want to do is we want to basically say this is the target position basically of where the block should be going. And then we need to actually say, so this is pretty simple. State, it's a Sokoban, if I remember correctly, set block, and it's going to be P. Let me rename that. I'll come back to that in a second. Did I mess up? Oh, so this is state, and this is P. C, original player position, right? So this is the original player position. Now we moved it, and we're going to set this back. But what we also need to do is Sokoban, and I may have this backwards or something. And this is going to be point add, and this is going to be the original player position plus command dot player direction, if I'm not mistaken. I could just be way off here, but we're about to find out. All right, that worked. So we go here, here, And by the way, the reason why we need the moved block is because if we don't have that and we start checking for the block, this thing will just start to follow us. And if you want to figure out why, you can just try and do it like I did and you'll see the problem. Always very unfortunate when you have the idea and then it messes up. So let's go into level 2. Let's go to, we have a malloc error. Okay, so we will do this in 2 parts. We know how to create it. Let me actually put it in, actually we know how to do it and it's in the video, so it's like, why even bother? I don't even know why I just made that, frankly. So let me go into here, I'm gonna go into here, and that worked perfectly. I'll do this, let's do a little bit more, and it worked. You can see some stuff's getting messed up, right? So let's fix that. So when we quit, you can see I think I'm calling commands.clear, but it doesn't really seem to be working. So front equals null pointer, back equals null pointer. Let's try it again. So that worked. Let me do this. I'm going to quit. Now I'm going to go into here again and let me see if that works. And let's go into here. That's working. Let's go into here, do some undos. And you can see we also fixed the malloc problem, where basically we assumed that it would be okay, right? That this wasn't going to be necessary, but it created a malloc error because it assumed that it wasn't a null pointer because we didn't explicitly say that. So when we switch levels, it just created a whole big problem. So let's go into the game C++ thing. We call clear here. When we do a restart, we also clear. In terms of U, we are actually changing the moves correctly, so that's good. Let me go to the save file real quick because I kind of want to test that more explicitly. So I'm going to set it to 100. Why not? I'll also set this to 20, right? Let's run it. I don't think I made any changes. So 120.239. If we do this, we do this. I made a mistake. Let me undo that, undo that. I'm going to do this, this, and you can see it already updated. So 13, and it took me a little under 8 seconds. And that's also just the optimal solution, I guess. I'm kind of curious if I can let me quit out, reload in just a second. Sokoban, play, let's go into here. Is there I guess I can do this, right? Boom, and now it should be, it's actually still pretty good. So let me again do this. Sorry for all the repetition here, but I just want to make sure everything is working. So this, boom, 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 boom. We should be less than 100 and more than 13, which we are 39. We run it again and we actually do what I believe is the optimal solution. We'll get 13. And yeah, so that is undoing moves in Sokoban. It works for blocks, it works for the player, and it's all because of the command pattern. And we had one little bug, which was annoying. But yeah, everything works now and looks pretty good. So I think in the next one, we'll go on to object pooling. And basically what we're going to do there is wherever we're calling delete, we're going to start using an object pool to keep things around. So that way we aren't remallocating a bunch of memory. When we clear everything, we'll give everything back to the object pool, and then we won't end up remallocating a bunch of memory again. So we're just going to be reusing memory just to make everything a little bit more efficient and friendly to people's computers. It's not necessary, but I think the idea is to say that we care and to act like it, I guess. Yeah. So yeah, I hope you enjoyed this video. I'll see you in the next one, and bye.